Over 1 million exposed machines online, all because of a remote code execution flaw which was buried in remote desktop protocol. With a wormable potential, just a packet to port 3389, and you had full system access, giving this a CVSS score of 9.8, critical. CVE-2019-0708, but you may know it as BlueKeep. The name BlueKeep came from security researcher Kevin Beaumont, which is a reference to Game of Thrones. So this bug hit remote desktop services, which is the thing behind Microsoft's RDP, which stands for Remote Desktop Protocol. Back in school, my IT teacher had remote access to all of our computers. If someone was messing about, they'd see a Word doc pop up on the screen with "Get on with some work." That's RDP. It lets you connect remotely to a Windows machine over its port 3389 and take full control. Desktop, mouse, keyboard, all through the GUI, or graphical user interface. It's used everywhere, by sysadmins, IT support, corporate networks, data centers, and that's what made BlueKeep so dangerous. This was pre-authentication, meaning the attacker didn't need any valid login, no username, no password, just network access to the target's RDP port. They'd send crafted packets, and if the machine was vulnerable, they gained control as system, the highest privilege on Windows. The flaw lived in how RDP handled certain messages during the very first session setup, before you ever saw a login screen. It was inside an old virtual channel called MST120, legacy code that has been quiet for years. MST120 wasn't validating input properly. One crafted message could corrupt the heap in the RDP service and let an attacker take full control of the machine. Think of the heap like a pile of sticky notes a program uses for temporary stuff. Variables, objects, whatever it needs on demand. Programs grab space when they need it and toss it away when they're done. A heap bug is like somebody crossing out and rewriting your sticky notes. That memory gets corrupted, and when the program goes back to use it, everything's ruined. The attacker can hijack the whole process. That's basically what BlueKeep did. Step 1. Recon and scanning. Attackers scanned the internet, or a target IP range for machines with RDP open on port 3389. Public search engines and mass scanning tools made it easy to find exposed servers. Step 2. Fingerprinting. They fingerprinted the RDP handshake, which is that quick hello between the server and the client, to identify unpatched window builds that look vulnerable. Step 3. Targeting the old channel. Once they found the target, attackers focused on the old RDP virtual channel. As this legacy channel didn't validate certain messages correctly, the message could corrupt memory in the RDP service and give the attackers a way in. Step 4. Turning corruption into code execution. From that heap memory corruption, attackers developed a reliable primitive to execute code on the machine, effectively running whatever they wanted at system privilege. Step 5. Deploying malware. With code execution, they could install backdoors, drop ransomware, run crypto miners, or exfiltrate data. So who was exploiting BlueKeep? Mostly financially motivated criminals. At first, they dropped crypto miners, cheap automated profits by hijacking server CPU without needing passwords. The campaigns quickly escalated. Backdoors appeared to give attackers a way in. Cobalt strike implants let them control infected machines and move laterally. And eventually, ransomware shut down hospitals, factories, and other critical systems. And BlueKeep was perfect for that job. Fast, fully remote, and easy to scale. There's no estimated public damage figure. Still, hundreds of smaller attacks likely cost victims tens of millions overall. The UK's National Cybersecurity Centre quietly found the bug and warned Microsoft. On May the 14th, 2019, Microsoft pushed emergency patches, even for out-of-support systems like Windows XP and Server 2003. Releasing fixes for legacy operating systems is rare, and that alone showed how serious this was. The patch forced the old MST120 virtual channel onto a fixed, static channel, channel 31, instead of letting it use dynamic channels whose numbers could change. Dynamic channel handling was the risky bit attackers abused to trigger the heap corruption. Locking MST120 down to a static channel made the communication easier to monitor and far harder to weaponize. CISA, the US Cybersecurity and Infrastructure Security Agency, urged everyone to enable network-level authentication. NLA forces users to authenticate before an RDP session even begins, so hackers can't just attack the service without valid credentials. Their other advice was simple: if you don't need RDP, turn it off, or at least block port 3389 from the internet. BlueKeep proved a few things. First, outdated RDP is still a huge attack surface. Just because the system's old or shouldn't be exposed doesn't mean it isn't. There are always going to be legacy boxes online. Second, attackers move fast. This wasn't a 0 day, but exploitation started within months of disclosure. With so many targets slow to patch, crime groups had a wide window to get in. Third, wormable bugs are still a threat. After WannaCry, defenders promised never again, and then BlueKeep came along. And the biggest takeaway: even critical patches don't guarantee fast fixes. Legacy systems, downtime fears, patch fatigue, they all slow response. That's why attackers still target old bugs, because they still work. BlueKeep might not make headlines today, but RDP vulnerabilities are still a big target. BlueKeep was a bug that could have been the next WannaCry. This time, fast patches and frantic defenders kept it from going global, but years later it still shows up in showdown scans, proof that old flaws never really die, and for attackers, sometimes all it takes is one forgotten server. CVE 2019-0708, BlueKeep, one for the archives. And if you enjoyed this, we've got new episodes dropping every week. Subscribe so you don't miss out, and give this video a like. I'll see you in the next one.